This is a question on principle of moments and Newton's second law. So in part A, define the center of gravity. So again, make sure you know the definition. Okay. Words that are often missing out is always the word entire, and also appears to add. Now B part 1 looks like a very simple question, but it's actually pretty difficult to articulate in words to explain why the two scales gives you different values. We must note that the person is lying closer to scale A. So what happens is if I take this point as the pivot as shown by my laser pointer, you'll notice that if I take this point as a pivot, then the moment caused by force X, the green arrow, and the moment caused by force Y, the blue arrow, they must balance one another. One is a clockwise moment, one is an anti-clockwise moment. And since the whole object is not moving, not rotating, the moments must balance by principle of moments. So you can see very clearly that if you take this point as a pivot, the distances on the left and on the right, the distances are different, and that is exactly what I'm trying to say here, that the perpendicular distances are different because the person did not lie in the middle of the plank. So this will result in a different value of forces for X and Y, so as to make the moments balance. Okay, so this is how we can answer this question using a moments perspective. Now there's this very simple perspective that we can also take because the person is closer to scale A. That's why scale A must support the weight of the person more, and hence scale A should have a bigger value. Okay, so that's for part B part 1. Let's move on to B part 2 to find the weight of the student. So in B part 2, to find the weight of the student, since we are given the values of the two scales, and the two scales are all outward forces, we can just add up these two outward forces, and this added value, this sum, will therefore be the answer for the downward force, which is the weight of the student. So that's exactly what I did here. 412 newtons is the answer. And again, you are using Newton's second law here, that the whole object is at equilibrium, it's not moving, it's not rotating. All the forces are balanced, which means all the upward forces must be equals to all the downward forces. So in B part 3, again, in B part 3, the question is a bit more challenging because we don't really quite know where the pivot is. So as I mentioned in a few videos previously, in cases like this, we simply just have to choose one of the points on the object as the pivot. And in this case, I will choose X as the pivot point. Now, if you are stuck at this question, I suggest you just pause the video, and now that I tell you let X be the pivot point, try to solve this by yourself using principle of moments. You should be able to get it. So do pause the video if you need to try. Now, we will now, knowing that point X will let it be the pivot, we will now look at the different forces and to determine the type of moments that it will cause. So the weight of the person will push down on the plank, and you will want to make the plank rotate in a clockwise manner. So that is the moment here with the respective values and distances. The outward force that supports the plank on the right side of the plank, that will want to make the plank rotate in the anti-clockwise moment. So plug all these moments into the POM equation, and that's how you can get the unknown distance d to be 0.74 meters corrected to two significant figures. So in part C, you are asked if the distance found previously will be different if you conduct this experiment on the moon. Now the answer is no, there's no difference in the result. This is similar to the MCQ question previously, so do watch that video if you need help with this. The gravitational field strength does not affect the application of POM. And again, I will illustrate using an example that this G value, gravitational field strength, it will appear in both sides of your POM equation, and therefore mathematically you can factorize it out and just cancel it away by dividing the whole equation by G. So this is an example of a POM equation. On the left hand side, which is on clockwise moments, I have a weight which is mg multiplied by perpendicular distance. Similarly, on the right hand side, I have another weight which is mg again multiplied by a perpendicular distance. And notice that g appears in both sides of the equation, and mathematically it will just cancel off without any effect on the overall equation. Now in part D, you are to discuss how the distance found will be affected if now we consider the weight of the plank. Previously, we mentioned that the weight of the plank is lightweight. When we say lightweight, means that the mass and the weight of the plank is like almost zero, it's negligible compared to the other forces in the object. So now, what if this mass of the plank is not negligible anymore, is significant? How will it affect your answer? So the quick answer is the accurate CG that we have found previously, actually it will be closer to the head. It will be shifted towards the head. Now, and the reasoning for this is as such. If we consider the weight of the plank, then we are looking at a new downward force right in the center of the plank. This new downwards weight of the plank will create a new clockwise moment about the pivot. And therefore, now there is a lot of clockwise moments already. So the clockwise moment caused by the weight of the student, which is this yellow arrow, need not be so big. Therefore, this moment caused by the downwards weight of the person, of the student, will therefore decrease. And the only way for the clockwise moment caused by the student to decrease is for the distance, perpendicular distance, to decrease. And that is the reason why the CG of the person, if the plank is of a sizable mass or weight, the CG of the person will be closer to the head.